So the title of my presentation tonight is Our Sustainability Challenges, Climate Change, Health and Animal Wellbeing. Well, as I've been introduced, I'm Pim Martens and I'm Professor of Sustainable Development. And I've been wondering over the years how important sustainability is in our relationship with the world around us, and especially the animals living within. What I would like to hope to do during my lecture is to illustrate how everything is interwoven, how our actions make a change in the environment, how this change in the environment will affect animal and our own health and well-being, and how this, by the end of the day, is at the core of the sustainability debate. It's very funny over the years when I start working on sustainable development that if you look at the concept, it's of course widely known. A lot of people use it, and I think recently is being misused more often than used in a proper way. But if you search through documents, policy documents, scientific literature, what all you have, and you look to the human health or animal well-being dimension of sustainability, you will find barely nothing. So both health, human and animal health, are very underrepresented in the sustainability debate. And I think this is a bad thing. If you look at this diagram, you see that I think that our health is being a kind of a sustainability index, an integrated sustainability index, how we are managing our natural and social environment. So we see in the left socio-economic developments, which have an influence on natural and social systems, with all the things in that. And by the end of the day, it will impact our health. And of course, animal health and well-being is very closely related to that as well. Also, if you look at animal health, it's very much dependent on how we are managing our natural and social environment, and it will also determine to a large extent, and we have experienced that recently now, our own health. So I think it's rather short-sighted that human and animal health is not more prominently part of our sustainability debate. And over the years, scholars have tried to do that, and there are many reasons probably why it's not, but I won't go into that detail. What I would like to do today is to show you how important a natural ecosystem is, how important proper management of our natural environment, how important respect for animals and nature around us is, not only as a right of its own, but also for our own health. If you look to sustainable development and our health, it's of course very difficult to define what's sustainable health. Is it we all live longer? Is it we all become more healthier? So I would like to reverse that question. I would like to say something about what are non-sustainable health developments. And I think here are a few of them we have seen over the last several years. I don't think that any one of you would think that zoonosis is something that is a very sustainable symptom to see how we're dealing with the environment. I think that there's still a huge number of people that lack proper food, lack enough food to feed themselves. Malnutrition is something that at least I do not consider to be sustainable. So there are lots of these symptoms of non-sustainable development in our health that you can see, and where you can actually also see that we are not moving towards a sustainable future. We are not managing our natural and social ecosystems, which I just showed you, in a sustainable way. Otherwise, a lot of these developments were at least less visible or less prominent present in our society. And I think the most recent example of the corona pandemic is again another illustration that we are not dealing in a sustainable way with our natural, social, and also economic systems. So these symptoms of unsustainable development are very important, and they are more easy to denote, to pick out of things we all see than trying to achieve a sustainable health, because that's very difficult to define. A few slides on the corona pandemic, and then I will go to the bigger picture in the terms of how we are actually dealing with climate and dealing with biodiversity loss and how that impacts our health. Before I come to the zoonosis, before I come to the corona pandemic, I would like also to show you that you can do similar as with human health, you can do with animal health and well-being. It's very difficult to define how we should deal with nature, natural environment, how we should interact with all the species that share the earth together with us. But you can look at these sets of symptoms, and there are many more, to see that in many cases we are not dealing that in a sustainable way with our fellow living beings. And these are just a few examples, and one or two I will go into a little bit more detail later on. I think a key example is the extinction of species. People say we are now in the 6th extinction wave, so we see in a very rapid pace species being extinct, and that of course is something I would not consider to be sustainable. And it can also lead to loss in ecosystem services and to the spread of zoonoses. A little bit more about that later on. I do also think that if you look worldwide, but also in the Netherlands, how we are treating our livestock, how we are packing our animals in very small places, in close contact to humans to produce our food. And we have seen also over the past several years and even decades, mad cow disease, foot and mouth disease, zoonoses. And these are all symptoms of non-sustainable interaction between humans and animals. Trade of animals and products, another example. A lot of animals and also their products, the bladder of animals or horns, ivory, they are being traded for whatever reason, and that's also something that can lead to a spread of diseases, and of course by hunting these animals to ecosystem disturbance. And maybe a little bit more closer to this part of the world is the overbreeding of pets, that we as humans have very specific wishes where we like to see in our pets. And that leads to dogs with 2 short noses, cat like this with 2 big ears, all for aesthetic purpose, at least in our eyes. So this is just a set of a few symptoms of non-sustainable human-animal interaction. And of course, this is not standing alone. It has also reasons why these are happening. In just example, I just mentioned the trade in animal and animal products. There is a huge economic market, a huge back market dealing with these products. And this is just an illustration of the price of, for example, the gallbladder of a bear, or the raw bile of the bear, the horn of a rhino. And you can see that this is very expensive. It lays between the price of gold and a cocaine price. So it's imaginable by these huge demands, huge prices, that people actually going for these kind of products and trying to make a living, or at least trying to illegally get more money out of it at the cost of animals surrounding these areas where they are being hunted. So a lot of these symptoms of non-sustainable development, both in our own health and in our relationships towards animals. Coming back to the zoonoses, the spread of diseases because we are not interacting in a proper way with our environment and we are not treating our animals we live with in a proper way. Zoonoses, as you may know, they comprise more than 70% of the emerging pathogens in humans. So diseases that being transferred between animals and humans are happening all over the time. And over the last several decades, we have seen an increase in this number of diseases. And these are just a few of them. Some of them arthropod-borne, for example, insects. Some are rodent-borne, mice, rats. Others are are being transmitted by bats. But you see that there are many of these diseases, some of them which are very famous, I think. Ebola, everybody knows about Ebola. Some of them are less familiar, but all of these diseases have locally and recently also very globally huge impacts on our health. And of course also, which is also very much underlighted, the health of animals as well. I will go into detail in a few of them in relationship with climate change, and then also in relationship with the loss of biodiversity and in our interactions with animals. But just to illustrate, it's not restricted to the tropics or the subtropic. It's not something that's far away as we experienced recently, but it's something that's very close by and is also very important in transmission of disease. An example we are all familiar with, I think, is the COVID-19 or the coronavirus, which is actually making the way across the globe. There are many theories, but the most trustworthy one is that it originated in the wet market in China. So lots of animals together with humans in a kind of a soup, virus soup, that actually caused the virus, the coronavirus, to pass on between animals and humans. And we see that spreading rapidly around the world. And these are in the early stages, and you all know what's happening now It's also the hotspot is now becoming South America. Lots of people are being affected and a lot of casualties. This is just, I think, a key illustration of what can happen. And this is not a surprise. I'm surprised that people act surprised because I think virologists, people that are into zoonosis, or people that know about ecosystem and system dynamics, they have warned for these kind of pandemics already for 20, 30 years. It was always not a matter of if it should occur, but when it would occur. And I really hope, and I will conclude also by the end of the presentation with some comments on that we learn from this current pandemic for the good. We'll see. But the coronavirus is making its way across the globe. So, wrapping up, our health is not always being sustainable because we do not manage our natural and social system properly. Human health, animal health is also not being considered to be sustainable. Zoonoses are a very important part of that. I think we all know at the moment, I don't need to tell because we all have learned due to the corona pandemic, that interfaces between humans and wildlife increases risk of zoonoses. So trade in animal products, wildlife hunting, and of course an increasing world population that encroaches in natural system, coming more and more in contact with animals, they are all risk for the spread of zoonoses. I already mentioned that a huge number of disease emergence we see are zoonotic in place, and probably there are many more to be expected in the next several years. Again, the corona pandemic illustrate all these points I listed also before the corona pandemic on this slide. And the other one is that the financial impact is, of course, huge. We are already facing economic consequences of this pandemic, and of course, they will last for the next months, maybe even years to come. It's not only climate, so that I must say. So although I will focus in the next part of my presentation on climate, biodiversity loss, and how it interacts with these diseases, it's also due to many other things. It's always a combination of multifactorial thing. It's a complex system, so also more than one factor is part of the issue. And I think in many of these climate change, spread of diseases, also globalization and travel is a very important aspect of the spread of a disease. But also urbanization and the demand for the products people like to have, animal products or wild animal beings themselves, they are all part of the problem. So they affect both humans and wildlife, and they interact with each other. I do like to stress that, by the way, that there is an inverse correlation between animal welfare and human health. So in parts of the world where also animal welfare is not being considered as a priority, we see often more damaging interactions between diseases spreading between animals and humans. So zoonoses, for me, although they will happen as being coexisting with animals for many years, they will continue to happen for the next thousands of years, but the severity and the increasing risk is probably due to all these factors listed here. So after this short introduction about how health and animal and human health should be at the core of the sustainability debate, because they are so important and they are so being influenced by everything we do in our natural, social, and economic system, I would like to dive a little bit into depth into climate change and human and animal health, and follow that because they are all interrelated between biodiversity, ecosystem functions, and our health. And they are both, of course, closely interrelated. Climate change does have an impact on biodiversity and ecosystem functions, and health of animals and humans will have an impact on that as well. So let's start with climate change and human and animal health. Health is, of course, not the only impact caused by changing climate. This is a list of potential impacts the climate change we will already seeing and we will foresee in the future will have. So we will see a change in species and in natural areas. So ecological zones will shift, and some species are not able to follow the increase in temperature. So some species, and not only animal species, but also trees, they are very likely not to be able to follow the speed of temperature change. Agricultural impacts. I think it's quite clear that we have these huge areas where currently maybe climate may be favorable for crop growth, but if climate change, if there will be droughts or maybe even too many rain in some places, that these areas may change, and we do not always have alternative areas in place. Water resources, more intense rainfall, sea level rise causing flooding, they all have an impact in floods, in water supply, etc. Also affecting coastal areas. So what we see, climate change, temperature, precipitation, sea level rise, they have a multitude of impacts. And again, I cannot stress enough that also these impacts, they are all interrelated. Changes in agricultural impacts will have an impact on levels of food production, will have an impact on our health in terms of malnutrition. Water resources can cause a change in water supply, has of course an impact on our health. Species, ecosystem services loss will have an impact on our health. Again, time doesn't allow me to go into depth in all of these, but I will just touch upon a few of them. And of course, in terms of climate change, I will focus on the health impacts right now. This is a demonstration. This is a thing in New York, and you may have noted also Maastricht University, at least the students at the university, have been also quite active in going onto the streets and having their voice heard in terms of trying to reduce the impacts of climate change, trying to reduce climate change itself. And this is, of course, something I agree. I think climate change is a health crisis. It's a lot of things, but it's also a health crisis. And this is, in my opinion, as I said at the beginning of my presentation, very important to realize. And health is for me not only human health, but also animal health and ecosystem health as well. Climate is also a very complex moderator of our health. On one hand, it can be a direct moderator of our health. An increased frequency of heat waves may lead to increased heat stress, so more people dying in very hot summers. So that is a relatively straightforward impact of climate change. I won't go into detail on that. More complex if climate change changes agroecosystems, for example, or climate changes spread of certain insects that may cause a change in disease as well. And that's one of the things I've done quite a lot of work on. So to illustrate also the complexity of the impacts of climate change on our health through this change in vector-borne diseases, zoonoses, I will focus in my presentation on that. But here, just to illustrate that there are lots of impacts of climate change to be expected in our health. And of course, there are modulating influences as shown by this green area, and we will adapt. We will not just sit there and do nothing. We will adapt, be it through technological means or be it physically or physiologically. In any way, there are a lot of things we can do as well. But still, we will see the impacts of climate change on our health in the next years to come. So climate change can have an impact on infectious diseases. Climate change can have an impact on diseases that are being transmitted by mosquitoes or by other insects. And there are many diseases that are being influenced and by being transmitted by mosquitoes. But I will just illustrate 3 of them. I will illustrate 1 animal disease. That's the impact of climate change on blue tongue in Europe. I will illustrate 2 human disease, Asian tiger mosquito climate suitability. And then finally, I will focus on climate change and malaria modeling. And this work we have done over the years in terms of mathematical modeling, trying to validate these models with field work in close collaboration with the University of Liverpool. So blue tongue. Blue tongue is a disease in sheep, mainly in sheep. It's being caused by a very tiny biting midget. And this midget is very climate sensitive. It lives in general with hot, humid, warm climates. It feels it's better in shape during these climates than when it's cold and in winter. This virus is very bad for sheep. It can cause sheep to be very sick and is spreading all across Europe. It can transmit very different kind of viruses. And as said, climate can have a serious impact in the spread of this disease. To give an example how we actually work with our models, we use the so-called R0 or R0. And you may remember that also from the discussions on television on how to control the corona pandemic. That's a measure how fast a certain disease can spread. And of course, it can be quite complex if you talking about diseases that are being transmitted between different species, between sheep and animals, between sheep and flies, midget, I means. Some diseases have even 3 or 4 hosts, then this equation becomes even more complex. But for blue tongue, this equation looks like this. Again, I won't go into detail, but what we did is we tried to relate all the variables in this equation with climate variables. Some of them have no relation to climate change. For example, the probability transmission of host to vector that is slightly or not related to climate. Others are very important if you look at the climate relationship. For example, the vector mobility rate is very important. The more suitable climate is for vectors, the more they will be present, and the lower will their mortality rate be. Hence, this R naught will be higher. So by linking this equation together with climate variables, you can say something about the spread of the disease if climate changes. And these are just a few examples of the models we run and the changes we have seen. These are typical examples for Europe, and we did also worldwide, but I thought it would be nice to focus on Europe for this disease. And you can see the changes in this risk measurement, because that's what it is, throughout time. And don't worry about the details, because you usually always run these kind of scenarios, these simulations with more than one climate model, because also climate models have different sensitivities. But what you see, and I'm now looking to the right 2 graphs, is that the change in this risk is becoming higher as climate changes. So the change is quite high in the United Kingdom and in Ireland, but also more northern parts of Europe become more risky for this blue tongue disease to be transmitted. And this is, by the way, a work this group in Liverpool together with us did in the early 2000s. And we presented this work at a workshop in Wageningen University. And at that time, there was no blue tongue in the Netherlands. So it was mainly restricted to Southern Europe. And I recall that a lot of the scientists, but also policymakers present at that workshop, well, they didn't believe that blue tongue would actually pass the borders of the Netherlands, pass the borders of Belgium, and move towards the northern parts of Europe. But in fact, reality proved that these models were at least indicating in the correct direction, because we've seen, and this is a graph until 2008, but we've seen the spread of this blue tongue disease also due to the more warmer summers going to the north of Europe and affecting sheep everywhere is being spread. So this is an animal disease. An animal disease, blue tongue disease in sheep, where transmission of this disease is being influenced by climate. But there are also many human diseases where climate interferes with the spread of the disease transmitting agent, the vector, or in this case, mosquito. Another one which is becoming more important worldwide is the spread of the Asian tiger mosquito. And we also have seen this tiger mosquito now in the Netherlands. And this mosquito can spread several diseases. It can spread probably the most best known dengue fever, but it can also spread chikungunya fever and West Nile virus. So what we did in a rather similar way as with blue tongue, we use different models to relate climate variabilities with changes in mosquito dynamics, and we see if the suitability of this mosquito will change if certain climate models will become reality. And the Asian tiger mosquito didn't exist in Europe. It is quite an invasive species. So it comes from Asia, hence the name Asian tiger mosquito, and it has been introduced in other parts of the world, mainly due to transport containers in ships carrying bamboos in which water was being conserved, and in the water was the eggs or the larvae of the mosquito, or by patches of water in old auto car tires that also cause these mosquitoes to being transported from Asia to parts of the world. And in Europe, it started in the Mediterranean, which you also see in the harbors of the United States and South America and Africa. Ships introduced the Asian tiger mosquito. Zooming in Europe, and there's also a more recent map, we see that it's also not only being introduced, but it's getting more foot on the ground. It's getting established on more places than before. And also in the Netherlands, the tiger mosquito is now being introduced, but the expectation is that if climate remains as is and becomes even more warmer, maybe even wetter, that also the Asian tiger mosquito will get a foot to the ground in this country. But you can see again that the southern parts of Europe are currently more suitable. The mosquito is already there, but with changing climate, just as the blue tongue disease, it will move up northwards into Europe. And of course, it then forms a potential of spread of diseases because it is capable to transmit these different viruses I just explained. Here again, the simulations about climate suitability of the Asian tiger mosquito throughout the years. And most important is there are sets of scenarios, and most important is the change, not the absolute value, but the change towards the year 2030, 2050. So in this time frame, we actually see with certain climate changes a very high increase of suitability of this mosquito. And empirical data, the spread of disease moving upwards is already confirming parts of these simulations. So that's the Asian tiger mosquito. Now let's look a little bit more into detail into malaria. And for malaria, we did similar exercise as with blue tongue and with dengue fever, also for Europe. But I would like to focus in my presentation on Africa for this disease, because very likely, although the malaria mosquito is still present in many parts of West Europe, it's unlikely that the disease will be transmitted on a very short notice, because you also need a kind of a reservoir of infection, and that's not just around in Western Europe today. But you can imagine that in the more vulnerable regions of the world, in Africa, for example, where there are hundreds of thousands of people dying every year due to malaria, that climate change may exacerbate these situations even further. And in our exercises, we did worldwide modeling continuously, and not only our work, but also that of other groups. The highlands of Africa turned out to be most sensitive. They were very much worried about changes in climate change because they already are surrounded by huge infectious diseases. And to give you an idea, this is the continent. The dark areas, the black areas, are the African highlands. So these are regions that are at higher altitudes. And these regions are generally less vulnerable for malaria transmission because climates are cooler. So these are huge plateaus, and lots of people live there with, up to date, not that much malaria transmission. These highlands are surrounded by high intensity transmission regions because at the lowlands in Africa, temperatures are far more suitable for malaria transmission than in these highlands. And these red stars, they already denote the sensitivities of these highlands, because these are the epidemics that have occurred over the last several decades, and they have caused a huge number of casualties, talking about thousands, tens of thousands of people dying additionally due to malaria because of a very hot period of time where the malaria mosquito could encroach into the hills and then actually be able to transmit the disease in the highlands as well. So you can imagine that with a decrease in temperatures, and lots of these highlands, they have now temperatures just not good enough for malaria transmission, but only with a small increase, that these areas can become favorable for transmission of this disease. So we did a few years ago, we did some work in Kericho. So we did some work in Kenya, where we had 3 study sites. We had Kericho, we had Lake Victoria, Kisumu nearby there, and we had Fort Tunnel in the middle. And what we actually did is we simulated the current situation. So the period in which we were is depicted in the top left. So you see actually that from the period 1991 till 1995, that only a few times malaria was being able to transmit it in the highlands. Kericho is a highland village. And during that time, we tried to look at the weather changes. So we had a weather station in the village. We looked at mosquito dynamics. So this is a typical puddle in which the larvae of the mosquito develop into mosquitoes. And we looked at the incidence rate, the number of children infected with the disease. And what you see, if temperature goes up only for 1 degree, you see that not only very limited periods in these 5 years transmission is possible, but you see that a far longer period of transmission can take place in these regions. So again, indicated that with only a small increase in temperature, malaria can go up in the islands. And during our study time, actually it was for the very first time that in this village, Kericho, malaria was being transmitted locally. So not coming from somewhere in the lowlands, but actually locally, and probably climate had an influence on that transmission level. So climate change, human and animal health, a very complex thing. You can look at it through empirical data, as we did in Kenya. You can say something about future impacts if you make computer simulation models of it, which I showed you for bluetongue in sheep, for malaria in humans, and also for the dengue mosquitoes. And you can do it with all the other vector-borne diseases as well. So we did it for many other diseases, but again, the procedure and the implications are more or less the same. The outcomes, increased climate change, continuing climate change is very likely leading to a change in spread and seriousness of many of these human and animal infectious diseases. I mentioned very much at the beginning that climate change has a multitude of impacts. It will also have an impact on ecosystems, on biodiversity. And no surprise, changes in biodiversity and ecosystem function will again influence our health and that of our animals we live with as well. So you have this very complex process between climate change, between biodiversity loss, ecosystem function change, and our health. And I try to tell a little bit more about this ecosystem function, biodiversity loss, and our health in the next few slides, and try to link them all together by the end of my presentation. So the global loss of biodiversity. I mentioned already that we are in the 6th wave of extinction. The estimate loss of species is many, many times higher than we have seen over the last several centuries, decades, even millennia. And if you see the change, it has exploded, the decrease had exploded, especially in the last 30, 40 years or so. People sometimes ask me the question, well, is that a problem? Do we really need the panda bear? Do we really need the tiger? Do we really need a kind of a tree or plant? So is biodiversity loss a problem? And if we don't want to lose certain animal species, okay, what does it then mean for our health? Are we impacted? Are ecosystem then completely changed due to loss of species? Of course, I don't have a precise answer, but I would like to illustrate some of these changes we might see with the next few slides. So I do think biodiversity loss is a problem, because biodiversity loss can change our ecosystem functions, and that in turn can change the way we live. And of course, species have a right of life of their own. So as you see in this picture, that sometimes the true value becomes clear if we lose something we valued. And you can also say only what's happening with our health, what's happening with loss of ecosystem function, and it's probably too late. But that's probably a very important thing to note. We only can tell, and if you can tell, probably the thing is too late. Because that's also one of the consequences if you consider human and animal health as a kind of a integrated index for sustainability, for sustainable development. It's also a very late indicator. So if we see changes in our health, if we see changes in animal health, then probably changes in natural and socio-economic systems have already occurred for the bad. So that's a consequence of changes in health due to changes in the systems we see. So the loss of ecological integrity, what does it mean for our health? Well, I would like to explain how the loss of single species can actually change the complete ecosystem. And I would like to illustrate that by a concert of Mozart. So if you listen to this concert, you can imagine that this concert is a very complex one. A lot of musicians are working together and they are making this concert to what it is. Eine kleine Nachtmusik from Mozart. You may also think that, okay, this sounds great, but what happens if we skip parts? What happens if we skip another part? what happens if we skip yet another part? Then you can imagine that at a given time, we will not recognize this as eine kleine Nachtmusik anymore. So this complex music, which sounds great, which is, so to say, an ecosystem of music, will not be the same anymore when we skip certain parts. And I think the same will apply for biodiversity loss and ecological integrity. If we take one species out of the ecosystem, maybe nothing happened. Maybe replacing a species doing the same as the species that has been gone. But you can imagine that if you have another species being lost and another species being lost and yet another species, that at a given time, this ecological integrity, this ecosystem will not be the same. It will be a completely different kind of ecosystem with different functions for us to give. And we are, of course, depending on a very complex ecological functioning ecosystem. We are part of the web, and changes in this web will also changes our health. A few years ago, I worked at Harvard Medical School, the Center for Health and Public Environment, and they have a very nice animation of how you could visualize that, and I would like to share it with you as well.
It looks like he was trying to tell us something about the web of life. And this, my friends, is the Priory of Species, representatives of the countless organisms that hold together the web upon which all life depends. The Priory has existed for hundreds of millions of years, but human beings have begun to dismantle it.
Dismantle the Priory? How?
In many ways, my dear, like destroying key habitats, releasing greenhouse gases which cause global warming, introducing invasive species, and over-harvesting species to the point of extinction. Human activity is causing extinctions at 100 to 1,000 times the normal rate, threatening the very existence of millions of species.
Why don't they stop this madness?
Because they believe the greatest lie ever told, that humans are not part of the web of life, that they can survive apart from it. But they cannot. Human beings' very existence may be threatened by the destruction of the web. Look here. When the tree dies, so too does the frog that lives in it. And frogs eat mosquitoes. Without them, mosquito-borne illnesses may thrive and become epidemics.
So, it's all connected.
Yes, and as new illnesses appear, humans will need the humble cone snails, which already have helped produce a painkiller 1,000 times more effective than morphine. These snails contain substances that may lead to hundreds of new drugs, if the snails are not extinct before these can be discovered. As species disappear, so too do the invaluable services they offer. You see, human health depends on the vast and complex web of life, as surely as does the health of penguins or fish. But if they don't stop destroying the web...
Well, I think it was a very good illustration that we are part of the web of species. So we are part of this intrinsically related ecosystem service the world around us provides us. And this diversity code movie is longer than the fragment I just showed you. So if you're interested, by all means, go to this website, and then you can see the whole movie based, of course, on the Da Vinci Code. So there are lots of functions ecosystem can provide. And I hope it's clear now that by having biodiversity loss, by having species extinct, some of these functions may diminish as well. And a few illustrations again on this. For example, the coral reef biodiversity. There are lots of potential medical powers in the coral reefs. So there may be a substance that can help us in finding medication for Alzheimer's disease or even treatments of cancer. But then we need a healthy coral reef. And what we have seen over the years is that increasing sea temperatures have caused coral bleaching, together with increased fertilizer use on land, which then being flooded into the ocean, and just only a slightly increase in sea temperature can cause coral to bleach, because corals are quite sensitive to the temperature of the water surrounding them. And in this map, the purple dots are the bleaching areas over the last several years. So lots of coral reefs in this map in the world are being, due to climate change, due to warm sea weather, are becoming less and less healthy. And what's coral bleaching? Well, this is an example. I just want to illustrate what coral bleaching is about. This is a healthy barrier. This is a healthy coral in the Great Barrier Reef in Australia. And when temperature goes up only very small, then we see this. And this is an example of a coral which is completely bleached. And after a few weeks, you see this. So this is a kind of a dead coral in which nothing is living anymore. And you see that's not only healthy for the coral, which by the way, also very important for coastal protection against floods and against storms. Of course, coral reefs can also have a very important economic functions for tourists, but most importantly, in my opinion, they are very, very important to have healthy oceans and maybe even for some medicinal power for our own health. Another ecosystem function that may go lost if we are depleting it, if we are trying to control it, if we are trying to get rid of certain species, is the biological control function. The movie I just showed you showed that you have a lot of frogs that eat insects. But of course, very close by, it amazes me also that the caterpillar, the oak procession caterpillar, is not being controlled in a proper way by biological natural control. Animals that eat insects and small mammals, they have an important pest control function. And this is something we, I think, do not use too often. Another issue is, of course, pollination, where a lot of birds and insects are being needed. And we see a decline in number of insects because of the use of very much insecticides and also pesticides on land. That has an impact on our insects as well. So this whole bee problem you know about is a very important issue as well. And that's an important eco-function that is going to be lost. If we get rid of these species, these ecosystem functions will not exist anymore, and the consequences can be for our account as well. So biodiversity and ecosystem functions are interrelated, and they are crucial for both human and animal health. I just mentioned a few of them, but you have also supporting functions of ecosystem. You have provisioning functions, you have cultural regulation functions. A lot of them, they all interact with our health and the health of animals. I will not go into detail, but the complexities even more what I just showed. Health is at the core of the functioning of our ecosystems, and we are actually depleting them. We are depleting the same functions because biodiversity is lost and we are encroaching in our environment. So what's next? If we look to the future, if we look to changes in our climate, if we look to changes in biodiversity, if we look to changes in our relationship with animals, what is to be expected? Of course, I don't know for sure. I cannot foresee the future. But let's imagine we have a future which is a kind of a business as usual scenario. And we did this analysis with a lot of people to come up with a kind of a comprehensive, consistent future scenario. So let's imagine we continue to focus on economic growth and technological developments. Let's imagine population will continue to grow as it has done over the last several decades. Then we still have environmental problems. Climate change will continue to exist. We will not solve it. We will see this biodiversity loss, and we will have still this currently mixed relationship with animals. We love them and we hate them. So this business as usual scenario will have an impact on our health. And I think you can have a twofold impact. For the more richer, so to say, developed countries, maybe we can deal with this. Maybe we can deal with zoonosis, a next pandemic, with our medical technology, because we'll also become maybe even more clever. But I do not think that the developing countries are able to deal with it. They probably will suffer the consequences, and a lot of the emerging infectious diseases, some of them which are discussed today, but many others that we may even not know at the moment, will emerge. They will become more risky and they will cause more casualties. And risk of zoonosis, like COVID-19, will continue to exist, and it will be a matter of time when we see the next pandemic. So this is a kind of a business as usual market world kind of scenario. But what if the situation goes even worse? What if we see a decreasing economic growth? What if we see more inequity around the world, environmental problems becoming worse, more rapid climate changes than we anticipated for, acceleration of the sixth wave of extinction, and where we see animals even more than we do today as commodities, as products for us just to use. Then I really think that it doesn't matter if you are living in a richer part of the world or not. Then probably emerging infectious diseases will pop up everywhere. And then probably even medical technology will not be enough to stop the emerging of these diseases. So then the risk, as we see now, will even become higher risk of zoonosis like COVID-19. But of course, we can also opt for a more sustainable world. We can choose for more social and ecological consciousness. We can choose for economic growth, but then within the limits of our ecosystems. We can try to stabilize population growth. We can try to reduce greenhouse gas emissions and stabilize the climate, trying to recover biodiversity, or at least trying to stop loss of biodiversity, and getting more respect from the animals we live together with and our natural environment. But even with all this, I think obviously we still face emerging of infectious diseases. We will not be able to live in a world, because that is the coexisting of us and other elements of our natural world, where there will be no risk of zoonosis. But at least we can minimize that risk. We can lower these risks of zoonosis by trying to be more respectful towards nature and ecosystems we live in. So in this sustainable world, the developed countries will probably reach a more sustainable health, or at least will suffer less consequences of unsustainable symptoms, as I showed you in the beginning. Developing countries may become at a level where they can also share our resources, and when a pandemic arises or a local epidemic, that they can deal with the risk that will occur in the future as well. So a transition to a sustainable society, that needs both a micro and a micro approach. It's not enough, I think, that we will have policies to reduce poverty. It's very important, of course, that we have also education on a micro level, that there are good plans in place on every level to teach people, to teach children, to teach women, to provide education. We need, and that's something we need to do on a macro level, we need to reduce greenhouse gas emissions, and we need to conserve nature. But of course, we also have our own responsibility. We can make a change as well. We can choose how to consume. We can choose how we move around the world. But for me, most importantly, I think what we really need is a paradigm shift. I really think that we might or not to focus on the economy, be it on a macro scale, be it on a micro scale, on every level. I think the economy should not be the core of our decisions. It may not even be our health, which happened in the early days of the corona pandemic, but to avoid future risk of pandemics like the coronavirus, or more locally outbreaks of diseases due to climate change, biodiversity loss, of other system changes, we may want to focus on animal well-being and ecosystem health as the key for a sustainable future. And maybe we all will be happy when the corona pandemic is over, but maybe we should make more and more work of the climate change crisis, because that's something that's coming and is already on its way for the next few years. And like the corona pandemic, we need to interact in a very soon way, as said, both on a micro and a macro level, in order to avoid huge consequences that we cannot deal with and actually can have a huge impact on not only our health, but on the ecosystem health and the health of the whole planet. Thanks a lot for listening, and I hope you will like my presentation.